Great.
Yes, great. Wonderful.
Good. So I will start now, yeah?
Yes, you can.
Mm-hmm. Yeah.
Okay. Okay, so yeah, today's talk is about Web3.js. This is the JavaScript library developers use to talk to their local Ethereum node. And I myself, I'm Fabian Vogelsteller. I built a flat file CMS, an open source content management system. I built a bunch of other open source libraries. I wrote a book on Meteor.js. It's a year old now. And I built the browser and the Ethereum wallet, which you can see inside the browser here. I'm working on Ethereum application right now. So Web3.js was originally called Ethereum.js, and it was basically a library like it is still like the standard library you use when you build a dApp, a decentralized application in JavaScript, to talk to your local node. Because normally a local node only speaks RPC, which is it's basically a way to call methods on some kind of remote object, and this runs over HTTP, almost all the content, all the function returns, and all the values are encoded in hex, and therefore it's not that easy to use. So Ethereum.js or Web3.js is basically there to make that simple. And it evolved over the last 2 years to what it currently is. And it definitely needs a refactor, means things need to be made better, more JavaScript style. And that's what I'm going to do, and that's what I will present today. So Web3.js basically evolved over this time. It was built by a bunch of people. Here, this is a video where you can see all the contributions and the contributors. For example, there's me and there's Marek Kotovic. Marek did a lot of work on Web3.js until where he left the foundation to work with ETHCore and built the parity client. But it was originally created by Jeffrey Wilke, and he is the one who wrote the Go client, Geth. So Jeffrey was the one who wrote the Go client and also started Web3.js as a very simple library. And after that, Marek Kotovic joined and made that even a more complex library, and I joined later and kind of overtook the project since half a year, almost a year. So, and there's also a lot of other people who contributed over the time, like Alex and Martin and so on, and a lot more people, but they did only small things. So, what is JSON RPC? So JSON RPC is basically, I don't have a mouse to show, but basically you write a JSON formatted request, like you can see in the first line. It's like JSON RPC 2.0 method ETH accounts. You send no parameters, and then the result will be also a JSON object. And in this case, it will be JSON RPC 2.0 result is an account, one account in this case. So this gives me back all my accounts, which my current node holds. In this case, it's only one. So if you use Web3.js, it will do this kind of calls under the hood, but you use it in a JavaScript way. So you basically just call web3.eth accounts, and you have the current accounts. So it is making this working with a node and over RPC a lot more easy. So smart contracts are basically all written in EVM opcodes, and it's written it's basically compiled binary bytecode, which the EVM can understand. And when you write a smart contract in Solidity or any other high-level language, normally you always compile it down to this binary bytecode which the EVM understands. And therefore, also all the function names you're using, they need to be compiled to this ABI, this called application binary interface. And this is a way to describe how you call functions in the EVM. So this, for example, looks like this. If I have a function called transfer on my smart contract, and this gets an address and a uint, then in JavaScript I would write transfer, give it an address, and give it like maybe 2000, whatever number. And Web3.js would, under the hood, convert that to hex and to the bytecode, where the first 4 bytes, this A9059CBB, would describe the function and all its parameters. It's basically SHA-3ing this and takes the first 4 bytes of that. This would be the function name. Then it would add the address, and then it would later add the uint. It would put a bunch of zeros in here, which I actually left out. So it would always make like 32-bit slots. And this is a way how the API then knows, okay, what function to call and with which parameters to call the function. So under the hood, everything needs to be translated to the API. And in JavaScript, you don't want to deal with the API because this would be way too complicated. So Web3 basically does that automatically. Web3 also has a bunch of other functions, utility functions. For example, to convert like hex to ASCII to decimal, converting from way values and to way values. So basically, the smallest unit in Ether is a number with 19 decimal points. And in order to interoperate with Ether on the blockchain, you only use way values. So you never send actual like Ether, like 1 Ether or 10 Ether. You basically just send like 1 quadrillion way or whatever the number is. Like a way with 19 zeros would be 1 Ether. And you have also other functions like checking for addresses and so on and so on. So basically Web3.js allows you to interact with contracts. It decodes to the EVM API for you. And it also gives you functionalities to check addresses and convert values and so on and so on. So the current Web3.js is a little bit a mess because it was grown over 2 years. So this means a lot of things are not on the right place, or there could be better, and so on and so on. So it grew to this like state where it currently is, but it definitely needs a refactor. It needs to be cleaned up. It needs to be probably changed, so that it's like better usable and more intuitively understandable by developers. So the main point actually to do a refactor when it will come to the version 1.0 is that we don't want to make breaking changes too often, because people adopt to using Web3.js in its current form, and they don't want to refactor all their code like every 2 months. So therefore I only want to make one big refactor, which I'm currently working on, which is the new Web3.js. So this looks like this, like the following. First, it will be socket based. This means currently under the hood it uses HTTP requests, and this is cool, but you cannot send push notifications down, and this is the problem. For example, when you want to subscribe to some kind of information like incoming blogs or event logs, you don't want to, before we basically always polled the node. So we constantly ask, hey node, is there new information? Is there new information? Is there new information? And so on and so on. And this creates like thousands of useless requests, which in 90% of the cases return nothing. So switching to sockets allows us to have a more, like a cleaner communication, because you open a socket once, you run all your function calls over the socket, and you can also subscribe to data, and you get the push of this data down once the event happens. And we already did this anyway over the IPC socket. This is the current layer the communication layer which the MIS browser uses. So basically, this doesn't run over HTTP because HTTP is insecure. It runs over IPC, where you cannot really spoof the messages. And if you want to attack this, you definitely need to have a local program running, and even then it would be complicated. So basically the main idea is we move to WebSockets and also IPC sockets, and we will deprecate the HTTP or only allow it for normal function calls. Then I want to modularize the structure so that you can only use parts of Web3.js and not need to require everything. So for example, if you only want to have the utility functions, you require Web3 utils and you get only the from way and toString and toNumber and all these functions. If you want to have everything, you require Web3 and you get Web3.e, Web3.sh, which is Whisper, Web3.e, which is and so on. And that's actually like one of the more important changes, and these changes are also because of what I just described with the sockets. So before we had this concept of filters. The problem with filters is that nobody really understands what it's supposed to do. So what for filtering here, right? So people thought, okay, I can filter for transactions. But you actually cannot filter for transactions. You can only filter for logs. And logs are events which are generated by contracts. So imagine you have a smart contract which basically tracks the deposit of funds. So this smart contract can have a function, hey, if somebody deposits, then fire a log. And this log will contain who deposited and how much he deposited. Deposited. So with the filter, you could basically say, hey, Web3.e filter, I want to watch contract at address X, and I want to watch log epsilon, and then I could call filter.watch, and I would get, function would be called every time there's a new log coming in. And under the hood, what we did, we basically were polling the node and asking constantly for updates. So we're constantly asking, so is there a new log? Is there a new log? And so on and so on. So this is not ideal, and this is also very confusing, so it's changed to subscriptions, which is a more common pattern, right? So you basically call Web3.e subscribe. As you subscribe to logs, you give it the options, which could be the address of the contract and the event or the log topic, and then you call basically subscription.on data, and you get your notifications. So this makes it first more clear of what you do, because you can also then subscribe to new blogs, and maybe in the future also subscribe to when transactions are mined. And we can add all kinds of subscriptions for all kinds of things, and we have to see what makes sense and what is scalable and what is performant and so on and so on. But in the beginning it would be new blogs and logs, and I think two others. So the subscription model makes it more clear. The only drawback with this is that the subscriptions are based on sockets. So this means when your socket closes, you basically lose your subscription. So what I'm built in Web3.js is that once it reconnects, it will auto-subscribe with your previous subscription. The drawback here is that you might lose one or two events in the middle. And we have to see how we are solving this over time, and will it be an edge case? Will it happen never? Will it happen often? And so on and so on. So the next the next important change is that before, basically you could only do either synchronous calls, means say, hey, Web3.eth accounts will return me always immediately the account addresses, or you could pass a callback and you make an asynchronous call. So the whole idea between the synchronous with the synchronous calls was that these calls will be answered so fast by the node that it doesn't really matter if they're synchronous or not. In JavaScript, when you make a synchronous call, it will freeze your interface until this call is answered. So the thinking back then was, because these calls are so short, your interface will never freeze. The problem is that's not true. Actually, you got quite a lot of lag and so on. So basically, using sync calls is a stupid idea, and not do that ever in JavaScript. But there was a lot of people who decided this back then, and it was like a lot of finding consensus between the people and so on. So basically, in the new socket-based Web3.js, you cannot make any synchronous calls anymore, because that's just wrong in JavaScript. So you can either events, or you can use promise-based chaining. For example, in this example, you see my contract.deploy, and you give it the arguments with which you want to deploy the contract, and you give it the data of the deployable code. So when you call this function, it will return an event emitter. And this event emitter can either call on error, or on transaction hash, or on mind, or you could say my contract.deploy.then, and then this would fire once the contract is mined, and then you could do something else. So basically it allows you to do either event-based action, or you can promisify this. You can basically use it as a promise. And this kind of merges these two concepts, because there's people who defend events and say that's the right way to do it, like in the Node.js community. Other people say it's promises. You can interestingly do this all together, and it works perfectly. And this is the way I'm going here with Web3.js, to basically give people the most flexibility. They could also pass in a callback, and this callback would be filed when it's mined, and do it the callback way as well. Not everything you see right now is final and is fully decided, so things might change. Maybe we only go with callbacks, and we build libraries on top which can wrap everything inside these events and promises, but this is still like in the making. So function calling was also a bit confusing, and I hope this is now a bit more clear. The problem with function calls, so if you call a method on your contract, the difference to a normal method you call in JavaScript is that actually you can call it in different ways. So, for example, you can simply make a call. So this is the second line. A call means execute that function on that smart contract right now and return me the current result. And this will basically just read from the blockchain. So you just call and you read whatever it returns. In the send function, what you would do is you would call that method, but you would actually send the transaction into the network. And this transaction could technically change the state of the contract, and therefore it is a transaction. So it means this is something which will happen once it gets mined. It will not return immediately. So in this case, it will return you a block hash, a transaction hash. And the event emitter on, it would give you an error if there's an error. In the transaction hash, it would give you the transaction hash, and it mined, it would call it with the receipt once it is mined. And you could also again chain it and only fires once it either is mined or when there's a transaction hash. This is still to be debated as well. But basically, you can see here, you can call the method with its parameters, and then you have three functions to call. So the call executes it immediately, the send will make a transaction and send the transaction to the function, and the first one, the estimate, will basically estimate the gas this method call will take. So this means if I'm having a specific function and I want to see how much gas this will use before I actually do it, with this kind of call, with the estimate call, I will get the amount of gas used. For example, when the amount is the same number than what I provided as a gas, it would show me that this function call was basically throwing. So it means there was an error somewhere in the function, or it was maybe an invalid call, and I know, okay, my function is wrong, or the user put something wrong in or so. And we could also in the future add more to this if you get more and different functions which are getting necessary. And here also many things of exactly what is returned can also be improved, but things like this have to be improved on the guest side, on the node side. What is also really important for smart contracts and for all kind of interaction is that you are able to encode the API directly and then get the API encoded. So for example, in this case, if I call myContact.encode API and I give it the method and the arguments, and that's probably also something we can add to the other function. So if you encode the API for this method, it will give you the first 4 bytes, which is the function name. The rest of the bytes is encoded hello, and the last 4 is encoded the 12,345. So this way you can use that data, for example, in proxy contracts. So proxy contract is, for example, where you have a smart contract where this smart contract will later call another smart contract in the future. So basically you make one call, and this call should only pass data through this proxy contract to another contract. So in order to do that, you need to encode the API which the proxy contract will call on the other contract. And this function, for example, will help you do that. So you can pre-encode your calls, path it through your proxy contracts, and basically interact with other contracts through other smart contracts. So yeah, and there's a lot more to come. For example, the refactor of the structure, improvements on the package sizes. I also want to remove the big number.js dependency and basically let developers choose what they want to use, what kind of library they want to use, if they want to use any at all. And so the refactor will be a big one, but it will be an important one to make Web3.js like future ready. So this is the talk, and I would like to also point to some of these websites which are really important. This is basically like the right place to look first. So first there's the JavaScript API wiki page, and I will send Tomoaki later all of these links, and he can like send them to you guys.
Okay.
So you don't need to write this down. But basically, the JavaScript documentation, this is the Web3 documentation, will tell you first how to install it, how you should add this to your application, and how you use callbacks, and so on, so on, so on. And it has the reference of all the functions. So, for example, let's say the accounts, get accounts, will tell you Web3 accounts, use it synchronous or asynchronous, get accounts, callback, and so on. And here's an example always. So you have to be aware that this documentation here is the old documentation. So in the refactor will change significant parts of the Web3.js object. So that will change for sure in the future. But this is the current version of Web3, and this is the documentation for the current version, and you can find this here. The second important piece is to understand Solidity, going to the solidity.readthedocs.io, going to the Solidity documentation. Here you will have explanations of Solidity, references of how things, all these things work, what kind of types you have, and so on and so on. So this is the go-to place to interact with Solidity, the Solidity documentation. Another great tool to just play around with smart contracts is Ethereum.github.io browser Solidity. And this basically allows you to write smart contracts in the browser. Here, we have our so this is our token interface. And for example, we could say, this is a very simple function, but basically this is a smart contract which allows you to create your own tokens. And you can then later here go, you can say use the JavaScript VM. So either you can use your local node, or you can use the JavaScript EVM. This means I could now immediately create this contract. And now I have this contract and all its function, and I could check the address, and I could call all these functions here and see what they will return me. So this is a way to interact with the contract, test what will work, how much gas it will use, and down here in this little field, you also have the JSON interface. So this JSON interface, this is what you need if you want to use a contract inside Web3.js. For example, if you go here, you check to is.contract here. To instantiate a new contract object, you need to give it the API array, which is the JSON interface. And this is this thing you get here. Basically, what it tells Web3.js, what are the functions, and what are the parameters, and what are the types of the parameters, so that Web3.js can properly encode everything so that the API will understand this. And here's also examples of how to do this in the documentation. And the last link, which is important, is Mist, because Mist allows you to play around with smart contracts, and it also allows you to move your money around. It also allows you to run a get node if you don't have one already installed. So you go to Mist, Ethereum Mist releases, and you can download the latest release here in the download section, or the previous release. But you should definitely only use the latest release. And in the hard fork window, you should either choose yes or no. If you choose yes, you're on the main Ethereum chain. If you choose no, you would be on the Ether Classic chain. So this is a choice you have to make. I obviously go with the main chain. And in the future, so in the next Mist version, that might not be there, this window anymore, and it will go with the main chain by default. So yeah, that's my introduction. That's my talk.
Okay. Thank you very much for the very nice presentation, and I would like to ask anybody to ask questions. Very nice chance to communicate with the Fabians. 多分いっぱい質問があると思うんでどうぞ。
So I understand many of this information is probably very new, and getting into this kind of field and technology is not that easy, because it uses very different concepts, and then you have all these new libraries and all these new ways of doing things. That's not the easiest thing to grasp. But I think it is really important to go to first, like, obviously English is very important, because the development community happens in English in the world, everywhere. And I'm from Germany. I can't. So English is important. And using the default communication tools. So one more thing I will show is the Gitter channels. So basically, go Gitter Ethereum. So Gitter is basically a chat application which is based on GitHub repositories. And there's a wiki page which links you to all the Gitter channels. So for that, it's mostly Mist and Web3 and Solidity and so weiter. So basically, if you go to Gitter, have this application you can download, and here is where the community asks questions, and here is where the community talks, and here you can get help. So strongly encourage you to use Gitter to ask your questions. And if you have technical questions you cannot get answered anywhere, then use Stack Exchange. I think it's this one. Use the Ethereum Stack Exchange. I'm not sure it's correct, honestly, what the link is. So, the Ethereum Stack Exchange basically is a place where you can ask questions and you get probably answers. It's not used that much, but it's used more and more. So if you have any kind of questions, how to go and convert a byte array to byte 32 in Solidity, there are people who help you. So first I would go to Gitter, second I would go to Ethereum Stack Exchange. And if you have any kind of answers for other people, that's perfect too. You can also help other people here and help them understand the technology better. I will give all these links to Tomoaki so he can
Yeah, Fabian, may I ask you some question? Yeah.
Sure.
Oh, okay. I'm not sure what is difference on the positioning of MetaMask and Mist. In short, how can I understand? How can we understand those two?
So the Mist browser is basically a standalone browser application, which is like its own complete application, and you run dApps inside and you manage your accounts, and the goal is that it's like the most trusted and secure way of interacting with the Ethereum blockchain and interacting with dApps, because everything will run locally. Mist will run its own local node, so it completely verifies the blockchain. And basically, because everything is running on your computer, you can be sure that you have control over everything. MetaMask is a Chrome plugin, so it basically allows any kind of application or web application you run in your Chrome browser to talk to the Ethereum blockchain. And it does this by injecting the Web3.js object inside the website. So once the website is loaded, it gets the Web3.js object, and therefore the website can interact with Web3, means with the Ethereum world. The problem is that MetaMask will talk to a remote node. So means your accounts will reside in the Chrome extension, means everything is signed in the browser, so it's signed locally, which is kind of safe, except that it's JavaScript, which might not be that safe, but it is definitely better than having it somewhere else. But it will, it basically relies on a remote server, and this is not the real ideal of decentralized applications, because what MetaMask does, or what you as a user do, you basically trust that this remote node tells you the truth, and you cannot verify. For example, if you execute a contract, and you get a return value like 21 or 2 or true or false, like I have money, so and so much money, you cannot know that it's true, because you never locally verified cryptographically that this. You basically just trust what the server tells you, and this server could be malicious and tell you you have zero balance, or you have 1 million ether, or this functions at yes or no. So MetaMask is a good way to allow people to interact with dApps fast and quickly, but if you really want to work with the blockchain, I mean, for example, I probably wouldn't put my family fund in MetaMask if I have there a lot of money. I rather would do this in Mist. But if I want to interact with a simple game where I deal with $10 or like 1,000 yen, I might not care, you know. So it's all about like what kind of use cases. And MetaMask allows people to get easily into the Ethereum ecosystem and use dApps without have to download Mist or download the blockchain and so on and so on. But Mist is like the real browser for dApps. So this is kind of like the differences, and I think they complement each other rather than make each other obsolete.
So, yeah, okay. Yeah, yeah, thank you.
Very interesting. Very interesting. Anyone? Questions?
When the new version of Web3 coming out? Do you think?
Yeah. So I'm working on it, and I'm getting constantly distracted. So the plan is 3 months, 4 months, maybe.
Okay.
Well, you can follow the progress on Web3.js. On the GitHub repository, there is already a 1.0 branch.
Okay.
You can just follow the 1.0 branch, and you can see what is done there. And also, if you are a good JavaScript developer and you want to help out, then you're free to help out, and you might be able to join the foundation as well. So we definitely need people to help out on this site as well.
Right. Thanks.
Any questions? Okay. Any questions? じゃああとは GitHub ですね。GitHub 質問は GitHub だということなので、そちらを見ていただきたいです。やっていいですか？最後に。佐藤さんどうぞ。はい。
Yeah. Thank you, Fabian. Yeah, it's a pleasure to it's really happy to come to Japan and your conference presentation and today's Kiev the communication between Japan and the Ethereum Foundation. That will be really good and we are happy to hearing about your updates on the UFCJS 2.0 and then we will make on top of it some kind of structure with things.
Okay. Fabian, thank you very much today.
Thank you so much, everybody, and I hope to make progress.
Thank you.
See you. See you. Bye. じゃあこれで終わります。これ切ります。いいですか？
バイバイ。
Bye.
Bye.
さよなら。
はい。いいですか？